I'm ready. This is what we're going to be covering today. We're going to try, I don't know if we'll get it finished, I don't really mind if we don't, because this section is not in your homework. Only section 2.1 and 2.2 is in your homework, and your online test I think is visible now, and that along with your homework must be completed by midnight Sunday. If you can't finish your homework, you can email me the usual way and I will give you an extension. But if you do that, you won't get the bonus extra participation point that you might want. Because every one of them in the bank is like, if you miss a day, it can be used to fill it up. So what's on the plate today? Well, we are going to do finding limits using a technique called the conjugate method. And we're then going to look at some special cases, really. These are just things that you can, don't fit into any of the other categories, but you can still find their limits. And then we're going to finish off, if we get that far, with question 1, which is a special case. So let me show you how the conjugate method works. Suppose you are being asked to find the limit as x tends to 3 of the square root of x plus 6. Take away 3 over x, take away 3. There, I'm just trying to create the question on the fly. What makes this the conjugate method? Dead easy to tell when you're going to do it. There's a square root. That square root could be here, it could be here, it could be down here, it could be down here. But you'll see a square root, right? So as long as you see a square root, you're going to be able to do that method. First thing I'm going to do is try brute force. So I'm just going to plug in 3. Well, I get the square root of 3 plus 6, take away 3. And I get 3, take away 3. Well, that's the square root of 9, which is 3. Uh-oh. We get 0 over 0. Isn't that bad news if you want to find a limit of anything? Remember, the name for that's called indeterminate form. Now, I'm going to be showing you in a few moments the technique. Let's just think as if we were the first people to tackle this problem, first mathematicians, how you might go about it. Well, just write the question down. So the thought process might have went something like this. I can't put x equals 3 in. When I do it, I get 0 over 0, so that didn't work. There's no way in the world I know how to factor that. I'm not even sure if factoring is an option. Would you agree? There's no factoring going on. So I'm going to have to figure out another technique. And the method that they came up with was kind of sneaky. You know, if you multiply a fraction by 1, you don't change the value of the fraction. You might change how it looks. So I could multiply the top by 2 and 2, right? 2 over 2. X over x. X plus 1 over x plus 1. I could do any combination as long as the top and the bottom is the same. So that would be a special version of 1. And so they went hunting for, I wonder if there's a special version of 1 that might make this question work. And the guy that they pick is called the conjugate, hence the name, the conjugate method. And it's the square root guy, but with an add 3, not a take away 3. Now, at first sight, you might think, I don't think that's going to do much good. All you've done is made the question even more difficult. But nonetheless, I'm going to keep going, and we'll show you that it actually does some good. Now, the two bottom terms, these two, all you're going to do is write them down as first guy times second guy. I am not going to FOIL that out. There's no point to do it. In fact, don't do it. It's probably going to make it worse than better. Just leave them together. On the other hand, the two top terms are going to get multiplied together using FOIL, and something real remarkable is going to happen. So I'm going to do that multiplication over here. So the top was the square root of x plus c 3, the square root of x plus 6, take away 3, multiplied by the square root of x plus 3, add 3. And we're going to do FOIL. So that guy times that guy is the f. Right, if you multiply the square root of x plus 6 with another square root of x plus 6, don't you just get x plus 6? That makes sense? Square root of x plus 6 times itself. Okay. Right. Now, O would be the outside ones, so it's these two. And it's going to be that square root times positive 3. So what you get is 3 lots of that square root. And then we'll do the I of FOIL, the inside two, which is these two. And you get negative 3 times that square root, gives you negative 3 square roots. And then you finish with the L, and the L is the last two, the 3 and the negative 3. And if you do those two, you get negative 9, and there's your FOIL. And do you see something remarkable happen to the two terms in the middle? Something really nice happened. Don't they kill each other off? Positive 3 square root, take away 3 square roots, gone. So now all I have left is an x plus 6 take away 9, which becomes an x take away 3. So when you multiply these two together with FOIL, don't you get a really nice answer? Can you see something cool that's going to happen next? What's going to happen? What will I do here?
The x minus 3 cancels.
Yes, you agree we're going to cancel? Leave a 1 behind. So what I'm looking at now is the limit as x tends to 3 of 1 over the square root of x plus 6 add 3. Do you see why I told you not to FOIL the bottom out? Because if you'd foiled the bottom out, you wouldn't have noticed that you could have cancelled, right? It would have just made things harder than it needs to be. Now, that guy is algebraically equivalent to that original. Looks a lot nicer, and it's got one other benefit. I can now plug in 3 for x. And the square root of 9 is 3, and 3 plus 3 gets me 6. And there's your answer. The limit of that ugly fraction is in fact 1/6. And that's the conjugate method. So let's try another one. What shall I pick? This is a version of question 9. Let's do the limit as x tends to 81. And we have 81 take away x over 9 take away square root of x. And if you plug x as 81 in here, you get 0 over 0. So we know that doesn't work. So now we're going to multiply by a special version of 1, the conjugate version, okay? Now the guy that's got the square root's important because that's the guy that determines what goes here and here. So this guy says 9 take away the square root of x. All we do is the same guys, but always with an add. Are you comfortable about how you know what conjugate to use? Right? I don't care what that is. That's nothing to do with it. It's the guy that's got the square root is an important guy. In this case, it happens to be in the bottom, which is fine. It can be in the top, it can be bottom, don't matter. So what I'll do now, once we've figured that part out, is I'm going to leave the top two untouched. So always do that, never do anything to them. You know, the two that don't matter. And if you multiply these two together, and you do it with FOIL, you will eventually get 81 take away X. Can you trust me that that's what would happen if I FOILed it out? But you can definitely, and you should FOIL it out yourself just to be certain about things. And again, in this particular situation, you get a cancel. Now, if you have a fraction and everything in the bottom gets cancelled, doesn't that mean that your answer is no longer a fraction? It just means it's 9 plus square root of x over 1, which is just 9 plus the square root of x. So we now have the limit as x tends to 81 of 9 plus the square root of x. And I can then substitute in 81 for x and get the answer 18. Kind of clever technique. I do not know, at least I've never read, the person who figured that technique out. But wasn't it kind of clever that he did? Or she did. So there is going to be some hiccups, some algebra things that you have to be careful of, like in everything else. There's always little twists, not all of them, but there are going to be some. So let's have a shot at this one. We're going to find the limit as x tends to 2 of 2 take away x. And it's going to be the square root of x add 2 take away 2. Okay, I can see a square root. I know it's going to be the conjugate method. If I plugged in 2, I guarantee you get 0 over 0, right? So we know that's going to happen. So I need to find the conjugate, the special version of 1 to use. Well, you look at that guy, the one that's got the square root. You do the same two guys, but with an add. Okay, now go to the next phase, where in this case I'm going to do that guy times that guy. But the two guys on the bottom, right, the thing and its conjugate, those two get multiplied out. And you can FOIL them out and you get the correct answer. Has anybody noticed that there's actually quite a shortcut way of knowing what these two things end up being when you multiply? Have you noticed that that's really a difference of 2 squares? So all you need to do is square that guy, which is x plus 2, take away square that guy, which is 4. So that guy squared, take away that guy squared. Now what's that going to look like? Well, we have a 2 minus x and the square root guy. And no, this is not a mistake. You do get x minus 2. So this one has one of those little quirks, right? Those little things you have to fix. Because wouldn't you be expecting to kill one of the guys on the top and that guy in the bottom, right? They should cancel, shouldn't they? Because that's kind of how the method works. And actually they do. 2 minus x is allowed to cancel x minus 2. But what's left behind? It's not 1. When you cancel them, you don't get a 1 left behind. What do you get left behind? If a minus b cancels b minus a, what's left behind? It's not 1.
It's a negative 1.
It's negative 1. In other words, your answer is negative. Right? So Just remember that little negative and you'll be fine. So we are now looking at the limit as x tends to 2 of negative the bit that's left. We then plug in 2 and we get square root of 2 plus 2, add another 2. And that's 4, square root of 4 is 2, 2 plus 2 gets you 4. And the answer this time is negative 4. Any questions about that? You follow the steps? Make sense? From picking the conjugate to multiplying them together to noticing that you can cancel, but the answer is negative. And lastly, substituting 2 in for x and getting your numerical answer. Any questions? Let's try another one. Each one of these, I'm trying to make it a little bit different each time. So this one is going to be the limit as t tends to 0. Square root of 6. Take away that guy. All over that guy. Well, there's square roots, so it's the conjugate method. That's the guy that's got all the square roots. So it's the first guy, add the second guy. First guy, add second guy. So far, so good. That's the conjugate. Instead of these two subtracted, the same two guys but added. Oh, but they're both square roots. Yeah, nothing wrong with that. They can both be square roots. Next is you would essentially FOIL them out and leave the two guys on the bottom essentially untouched. Now, if you multiply this by that and you do FOIL, you will get this guy squared, which is 6 plus t, take away this guy squared, which is 6 minus t. Do you notice I put a bracket around the second one because it's a whole thing that you're subtracting, right? It's first guy squared, take away second guy squared. And what does this become? Well, 6 take away 6 goes away. T take away t gets me 2t. Oh, that wasn't too bad. Just came out as 2t. Of course, we can now cancel. That t will cancel out that one. And we're now going to be finding the limit as t tends to 0 of this fraction. And this time we can plug in 0 and we can get something that works. So it's going to be 2 over 6 plus nothing is square root of 6. 6 take away nothing is the square root of 6. And so that gets me 2 on the top. A square root of 6 added to another square root of 6 just means you've got 2 of them. And now we should do style points if it's possible. Can we simplify this fraction in any way?
One over square root 6.
Agreed. Just cancel the 2's and get 1 over square root of 6. And WebAssign would probably accept that, but I don't think we should leave things like that because that's not really good math. Shouldn't we rationalize the denominator by doing that little trick? And what do you get then? You get square root of 6 over 6, and that's the answer I would be looking for. Are we good? You like that method? Comfortable with it? Let's try another version. This is similar to 13. It's going to be the limit as x tends to 25 of 5 take away the square root of x over 25x take away x squared. So as I said, I'm trying to pick conjugate method, but each one maybe just get a little bit different. What is the conjugate going to be for this question?
5 plus square root x.
Move on to the multiplication stage. In this case, the guy and his conjugate are the ones that are going to be multiplied. And on the bottom, I have those two guys. Now, if you multiply this one by that one, you get the first guy squared, which is 25. Take away the second guy squared, which just gets you an x. You comfortable with that? Oh, we're stuck. We should be cancelling right now, shouldn't we? But evidently, things aren't quite the way they need to be. While I write this down, why don't you look at this expression and see how you fix it? Is there anything you can do that might help us?
Factor out an x.
You agree? It's just a matter of sucking out an x. Now, if you do that, these two cancel and there's a 1 left behind. And so we now have this fella. Now we can plug in x for 25. And we get 1 over 25 times 5 plus the square root of 25. And that becomes 25, and that's 5 and 5 is 10. So as an exact value, the answer is 1 over 250. So the limit of this original question, this ugly fraction here, as x gets closer and closer to 25, this fraction will get closer and closer to that guy. Are we still good? I'm just looking at another choice here. So which one I want to do? Let's do this one. I'm not quite sure what this one's going to look like. It might be horrible. It might be quite easy. Just not 100% sure yet. So this one is similar to question 14. So it's the limit as x tends to -24 of the square root of x squared plus 49 take away 25 over x plus 24. It just looked kind of awkward, so that's why I kind of chose it. It's going to be x squared plus 49 add 25. It's going to be the square root of x squared plus 49 add 25. Won't do anything to the 2 in the bottom. And if you multiply this guy times that. Now I'm doing the shortcut here. If the shortcut doesn't work for you, just take those guys, you know, find a piece of scratch paper and go first guy times second, then do F, O, I, and L, right? Just do the FOIL the long way and it will work. The short way is first guy squared. Well, if you square that guy, you get x squared plus 49. Take away the second guy squared. Well, take away 25 squared is 625. Ooh, that does look interesting now that I see the numbers. Okay, won't risk it doing the calculator. If you take 49 and subtract 625 from it, you get 576. And no, I haven't made a mistake, although very quickly I do. That is actually the right number. And you should be thinking at this point, where's the cancel, right? Where's the meat? How am I going to get this thing simplified? And we kind of hit a little brick wall. In fact, the only guy I think is even vaguely workable, would you agree? I should be able to maybe change this in some way, right? I should be able to work on it. While I'm writing this guy down, maybe you can think about how to factor the top guy.
How to factor it?
It is factorable, yes.
You can factor it by timesing x plus 24 times x minus 24.
Yeah. Would you agree there was a kind of little clue in the bottom? You see that x plus 24? Didn't you know that that had to get killed, right? So didn't that give you a kind of clue what happens in the top, right? So see if the top ends up being some ridiculously awkward, you know, x squared minus 92x plus 1040, you know, one of those kind of really massively big, massively ugly trinomials. If you already know what one of them is, doesn't that really guarantee what this one is? You can see that's a very big difference of 2 squares. Check it out, but it works. Right. So there was a kind of clue on what it needed to be by looking at the bottom. So these two cancel. And now we are looking at the limit as x tends to negative 24 of an x minus 24 on the top and quite a lot on the bottom. Any questions about that? Are we comfortable about the steps and where we are now? You feel good about how it got there, right? Okay. Then, time to plug in negative 24. So negative 24 for x, take away 24. A really ugly square root, which I'm going to do on my calculator because I have no intention of trying to do that in my head. Right, so the top two get you negative 48. Let's see what the bottom looks like. It's the square root of, I have to put a bracket around it, negative 24 squared plus 49. There we go. Oh, it's 25. And 25 plus 25 is 50. Of course, I can simplify that down to negative 24 25s. So conjugate method, if you see a square root, you're probably going to do this question that way. And let's move on to the next topic. Or maybe not. Do you want me to do another conjugate method question? Have you any questions you're not 100% sure about before I move on? Let's make sure.
What
Yeah.
happens if you have a square root, but there's no like if it's just the square root of x, not like the square root of x plus 2?
Okay, so if you had a question where there was like a square of x, kind of thing, right? That is that what
Like
you're asking?
without the -3.
Oh, you mean we are +3?
Oh, just the square root of x.
Oh, wow.
Like over something.
Right,
like what
over
would the
something. Yeah, like
conjugate
that.
be? Yeah.
I can't make a question up where I'd be able to get the answer unless it was something trivial, like you could just plug the number in. You wouldn't need to use the conjugate. So the conjugate, the main feature of the conjugate is it has a square root, but the other feature is it has to be minus something. So it's got a square root. Have you noticed all of them are the square root of something, take away something, right? They always have that look. So if that's not there, then it's not the conjugate. If it's just that on its own, it's not the conjugate, right? In fact, if it's that, it's not the conjugate either. In fact, the chances are you could just plug in the number for x and you get an answer, right? You wouldn't need to do really much work, right? You could just replace x by 10 and the thing would come out without any problems. Interesting question. That. Yeah. Anything else? So the ones I'm calling special cases, because I couldn't think of anything else to call them, are that there are questions out there. This is the two that I'm going to be picking on, 16 and 17, where let's do the limit as x tends to 5, and it's going to be 1 over x, take away 1 over 5, and on the bottom is going to be x take away 5. So just looking at that, would you agree we haven't done anything that even vaguely looked like that? So first thing I'm going to tell you, and I think this is obvious, that is not going to be a conjugate method. Would you agree there isn't any square roots? So you know that method's not the one to use, and that's fine. Would you also agree I can't factor anything? I don't even see anything that's factorable. So I'm not going to do the factor and cancel method. And if I plug in 5, 1/5 take away 1/5 is 0, and 5 take away 5 is 0. Don't we get that horrible 0 over 0 issue, the indeterminate form? So I can't even do brute force, which is what I call it when you plug the number in. So we have to, in these special cases, we have to figure out algebra tricks to rewrite the original in a way that makes it easier to deal with. Well, I'm going to use a trick which I've kind of used before. If you have a fraction and the top has fractions or the bottom has fractions in it, you can rewrite it nicer by multiplying by a special version of 1. And I am going to multiply by this special version of 1. Kind of, didn't the conjugate method use its own version of that, right? Special version of 1. I didn't multiply just by 5 over 5. That would have, that would have taken care of this 5th. It would have made it nicer. And I didn't just do x over x, and that would have taken care of this. Can you see why I needed a 5x top and bottom? And what's going to happen now is that I should be able to multiply the top, these two guys, by 5x. Well, 1 over x multiplied by 5x, you end up with 5. And 1/5 times 5x, or negative 1/5 if you prefer, you get negative x. And on the bottom, you have 5x, x minus 5. So all I've done here is get rid of those fractions, and I managed to do it by multiplying the numerator and denominator of this expression by 5x. Sometimes my x's don't quite make it together. This happened today as well. Can I cancel anyone in the top with anyone in the bottom? Sure can. But when I cancel these two, what is left behind? It's not 1, it's
-1.
-1, right? So that means that we are now, you probably don't need this line, but I'm going to put it in. You've now got that guy. So remember that ugly fraction is actually the same as -1/5x. That's dead easy to do because you can just do the brute force, replace x by 5, and you now have -1/25. Do you feel comfortable about that? Now, each one of these special cases is going to be special in its own way, right? So I'm not going to do another one that has a fraction like this, right? We're going to do something different. And the next one we're going to do looks like 17. If I can kick this out for a minute. There we go. In question 17, we are being asked to find the limit as, oops, that's meant to say h, as h tends to 0. Okay, what are we going to do with this? Because there's nothing to cancel, right? I could go through all the things that don't work, right? So we're going to have to figure out something that does work. Any suggestions about what I could do to the top? I don't think there's much you can do at the bottom, but what I could do at the top. I think I see factoring out, right, multiplying it out. Now, x plus 3 cubed is a little bit messy because you're not just multiplying x plus h by another x plus h, you're actually multiplying 3 of them together, right? That's not a common algebra thing for you to do. So what I'm going to do is I'm just going to multiply these two together, right? And you do that with FOIL. And to save some time, can you trust me that eventually that's what you would get if you did x plus h times x plus h. Okay. Now I'll introduce the third one. In other words, I'm going to multiply this guy by that guy. And although it's not FOIL, it's very similar to FOIL. What you do is you do x times this one, x times this one, x times this one, h times this one, h times this one, and then finally h times this one. Do you see how that generates 6 different pieces of your answer? So from the top, x times x is x cubed. X times this guy is 2x squared h. X times the one at the end is an h squared x plus. This times this is an hx squared. This times this is a 2x h squared, and this times this is an h cubed. So far, so good. Now, if I look carefully, do you notice that that guy and that guy can be combined? And that will get me 3x h squared. And that this guy here and this guy here can also be combined. And that gets me 3x squared h. I still have an x cubed at the beginning, and I still have an h cubed at the end. You're comfortable about x plus h cubed now? You'll feel good about that. So let's put it in here. So it's x cubed, 3x squared h, 3x h squared, and an h cubed. And then don't forget to take away x cubed. Things looking good so far? Let's see what happens next then. Well, that x cubed will get killed off by that. And so I'm now left with 3x squared h plus 3x h squared plus an h cubed, right? That's as far as we've got. Each step hopefully is getting us closer to what we need. Can you see anything that might be helpful to do to the top expression?
Factor an h.
Okay. If you take out an h, you get 3x squared, 3xh, and an h squared. Can you see why that's a good idea? Because I can now cancel these, and we are simply going to be left with 3x squared, 3xh, and an h squared. Right. Technically over 1, but nobody would write it that way. Now, at this point, I can just make h 0. So I'll get 3x squared, 3x times nothing, plus nothing squared. Well, that disappears, and the answer is 3x squared. It's okay for a limit to be an expression. It's okay to be 3x squared, right? It's okay to be 42 as well. I mean, that can happen. In this case, it's 3x squared. Any questions? Okay. So I can check that off my little list. So we are bang on schedule to complete this section, which is good. I'm still not going to add it to the test or add it to the homework. So this section that we've just finished is not due this Sunday. It won't be due to next Sunday. And it's not going to be on the online test one either. It will be on next week's online test. But I strongly suggest that you do it anyway, because that way you'll have less work next week, right? And if you've got the time, you know, do it. Secondly, it's fresh in your minds, right? This conjugate method's not easy. You know, if you wait a week, won't you kind of think, I wonder what I did, right? I've forgotten the bit in the middle or something, right? So we try to avoid that. So let me show you the last thing that I haven't done, and it was question 1. Hopefully you are looking at question 1 right now, are you? Right. And one of the reasons I avoided question 1 is if I did it first, it would just get your brain in the wrong place. What you've got here is a very special situation. You're being told the value of a limit, right? So the limit is x tends to 3 of f of x is 1. For the function g of x, it was -4, and the function h of x, it was 0. So they're all being found at a limit as x approaches 3. And now you're going to be asked to find the limits if they exist. And if the limits don't exist, you just put DNE, does not existing. Well, you've never seen this, but I think logic might come into play here. If I wanted to know the limit as x tends to 3 of f of x plus 3g of x, would it be reasonable that the answer would be 1, because that's what f of x is equal to, plus 3 lots of -4, which is what g is equal to, and I believe that answer is -11. Does that make sense? And that's exactly what you do. Right. Now, if you wanted to find the limit of g of x cubed, wouldn't you basically just take the value of that limit for g of x, which is -4, and then wouldn't you cube it, which I believe is -64. In my question, at least, the next one is the square root of f of x, and that would be just the square root of 1, which is 1. Is it any? That one's okay. Oh, here's one that's not doable. G of x over h of x. Well, g of x is -4, and on the bottom you could put 0. Do you see why that one doesn't exist? So in that question, you would do D, N, E. And in this last one, it's a G, an H, and an F. So the G is this guy. The H is this guy. So -4 times 0 over 1. And I can do that in my head. It's 0. So that was the question 1. Basically, if you tell me the value of a function or multiple functions, I can then tell you the limit of any combination of them, right? F of x plus 2g of x, you know, that type of thing. And we should finish with a joke.